Here's a GRE arithmetic question. Let's take a look. If x, y, and z are positive numbers such that 3x is less than 2y is less than 4z, which of the following statements could be true? Indicate all such statements. Well, let me start by asking you a question. What is the most important word in this problem? And no, it's not all, even though that's underlined. That just tells us that one or more of these answers has to be correct. The most important word to understand the logic of this problem is could. And let me explain that for a minute, right? A lot of times on the GRE, we see the language must be true. Which of the following must be true? But here, it's asking which of the following could be true. In other words, if we can find one example of it being true, that's it. We got it, right? So what we're going to do is go through each and every one of these, right, and try to make it true just one time, given the information that we have in this problem right here. So let's start with this. X is equal to y. Could this be true? Is it possible in one case for this to be true? Well, let me look at the x and y terms that I have. 3x is less than 2y. Ignore 4z for just a minute. I mean, it's bigger than both of them, so we don't really care about it. We're just interested in x and y here. Is it possible for these to be equal to each other? Well, let me try to make them both 1 or 2 or 3 or a billion. And as you test those numbers out, what you see happens is the left side is always going to be bigger than the right side, right? Because if x and y are equal to each other, if they're both 1, for instance, right? This number is being multiplied by 3. This number is being multiplied by 2. That side's always going to be greater. So it is not possible for this one to be true. I can't make it work. Keep trying if you want to, but it doesn't work, all right? Okay, how about y is equal to z? Well, let's look at these two terms here. 2y is less than 4z. And this is an inequality, so if I divide both sides by a positive number, I'm totally okay. Let me do that. Divide both sides by 2, and I get y is less than 2z, just to make my life a little bit easier, right? Well, is it possible to make these two equal to each other? What if they're both 1? Is 1 less than 2 times 1? Yeah. What if they're both 2? Is 2 less than 2 times 2? Yes, it is. In fact, this will always be true, right? It will always be true. We don't even need to go that far. The minute we find one example, we're set, but this one is in, right? Because we found one case, 2, 3, 4, 5 cases where it's true, and so it could be true. All right, how about this one? Y is less than z. Well, I'm dealing with the same two variables, so let me take this exact same relationship here, and I have y is less than 2z. Is it possible to make y less than z? How about y is 1 and z is 2? 1 is less than 4? Yeah, done, right? That's the magic of could be. All I need is one case, and I'm set. Okay, here comes the harder one. X is less than z. Well, let me take the values that I'm looking at, or the variables that I'm looking at. 3x is less than 4z. You might look at that and say, wait, hold on. What about 2y? You just left 2y out. Well, here's the thing, right? If 3x is less than 2y and 2y is less than 4z, then I can absolutely say that 3x is less than 4z, right? I don't need this one standing in the middle to say that this one is smaller than this. So let me write that right there. Okay, now, this one's a little harder to think of. Is it possible to make x greater than z and still have this be true? Well, it is, but to do it, we have to kind of dip into the decimal zone. And here's what that looks like. What if we make x equal to 1 and z equal to 0.9999999, like very, very close to 1. It's still less than 1. Right? Well, 3 times 1 is 3, and 4 times 0.9999999 is 3.9999999. So I have found one case where this is true. And if you're wondering how I knew to do that, right? Like how I knew to go to decimals, let me put it this way. Interesting things tend to happen with decimals, right? So if you're only testing out integers or whole numbers, maybe to really, really check yourself, use decimals. So the correct answer to this question is 2, 3, and 4. Answers 2, 3, and 4. For more GRE tips and tricks or to sign up for my live online course, follow the link on my profile.